that did not hear. So, this thing had these stumps, yes? I was at the bottom of the barrel. I was as low as you could get. How can I teach this without being able to factor it? And then, gleam of inspiration came upon me. And I said to myself, I said, Sal, you do not need to factor this because you got data. You got data. What data? I asked. Who remembers the graph of this function? Where is my graph of this function? Do I still have it here? Yes, I do, with a bunch of writing on it. Let me erase the writing. There's the function. What do I know about this function? Trey, what do I know about this function? What do I know about this guy? It won't zoom with that. What do I know about this function? What is special about this function? Hey, what's special about this function? What can you tell me about this graph? We graphed this yesterday, right? What can you tell me about this graph? What points jump out at you? This point jumps out at us, right? This point jumps out at us. And what other point jumps out at us? 3. Okay? So, x equals 3 is a solution to... Oh, it's this one. X equals 3 is a solution to this equation. X equals 3 is a solution. Now, I'm going to rewrite this factoring out that negative 3x that I factored out earlier. Right? That leaves me x cubed plus, or no, not plus, minus 7x squared plus 16x minus 12. So, if x equals 3 is a solution to this one, if x equals 3 is a solution to this, then x equals 3 is a solution to this because they are the same equation, are they not? They look different, but are they the same equation? What do you think, Rose? Yeah, they're the same equation. Right? Right, John? No. No? Yes.
Yes. Yes.
How about we use weak space? You got good ones.
Whoa. Whoa.
What? No, I'm not making fun of your ears, David. I'm just saying you got, they work, right? You get it.
I get it. I do.
All right. Now, here's what I want to ask you. X equals 3 is a solution to this, right? What else is a solution? Let's go back to my graph. X equals 0 is a solution as well, right? X equals 0 is also a solution. Let's look at our equation. If I put 0 in for x, right? What does x turn that thing into? What does 0 turn this thing into? 0 cubed is minus 7 times 0 squared, 0, plus 16 times 0, minus 12. Negative 12, right? All that times negative 3 times 0. So what's this thing equal when x equals 0? This side is negative 12. But I'm taking everything in the parentheses and multiplying it by what? Negative 3 times 0. So what is the value of this function when x equals 0? 0. So 0 is also a solution. This right here should tell you or show you the relationship between factors and solutions. Right? Because I can say, well, negative 3x equals 0. And if I solve for x, I divide both sides by negative 3, right? And therefore, x equals 0. Okay? So, I've taken a factor, I set that factor equal to 0, and I get me a solution. And this solution agrees with the solution on the chart, on the graph. Now, I have a solution on the graph. What's my solution I'm going to use? I'm going to use x equals 3. And I'm going to come up with a factor. What does that mean, Tabitha? I'm going to start with x equals 3. Oh my goodness, big. I'm going to start with a factor, or I'm sorry, a solution of x equals 3. And I'm going to come up with a factor. What do all my factors have to equal? So when I'm analyzing this factor at this point, what does my factor equal at that point? Now my solution equals 3. X equals 3. But remember, in polynomials, factors don't look like this all the time. Factors don't look like that. Factors look like that, or that one is right here. This one is this solution right here, but they also look like this. When x equals 3, my factor has to equal 0, right? So how do I get to this point? X equals 3. And then I want to devise a factor that equals 0 when x equals 3. So what do? I make this side equal to 0. How do I make that side equal to 0? Subtract 3 from both sides, right? So I have minus 3 here, and minus 3 here. What do I get on the right-hand side? I get 0, right? 3 minus 3 is 0. What about on the left-hand side? X minus 3. That is my factor. X minus 3 is a factor. Now, that's an important part conceptually with what we're doing over here. It's an important point conceptually. So remember, we take the solution, x equals 3, and we divide it to get a factor. This is my factor. Now, if it's a factor, what can I do with it and this guy? If 2 is a factor of 6, what can I do with 2? Yeah, I can take 6 and divide it by 2 and get a whole number, right? Thank you. Now, I'm doing the same thing, except instead of with numbers, I'm doing it with a binomial. So I'm going to take this guy, I'm going to divide it by x minus 3, and I'm going to get some other polynomial without a remainder. So let's do that real quick. So I got x cubed minus 7x squared plus 16x minus 12. X cubed minus 7x squared plus 16x minus 12. And I'm dividing it by what? X minus 3. So do that division real quick and see what you get. We're back to polynomial division, ladies and gentlemen. Who remembers? You guys thought we were done with this, didn't you? Yeah. Actually, no, it's not a 5 problem. One problem. With 18 parts. No. I wouldn't do that. I wouldn't do that. I am so disorganized right now. It's not even funny. Divide 2. Yeah, we're on F. I can too, but I can't handle it for like 3 months. I can't handle work for 3 months either. That's square root, so it's just division, right? And then the other thing. Okay. Okay. So this is part. Alright, so when I divide polynomials, first thing I'm going to do is more than one. What's what I have to multiply it by to get it there? Or in other words, how many times does x those are? X, you're right, x cubed goes into x. One time. X cubed goes into itself once, right? Another way of asking that is okay, so x cubed is x times x times x. So I start with x. Look what I multiply x by. X squared. Okay, that's what I said. Okay, so bring down x squared, right, all the 7x. Okay. Alright, I'll have this video okay. Now I take that x squared and I multiply it by this whole x minus 3. So x squared times x. X squared is close to negative 3 is 4. But that right here. Now we're going to do Right, what did you get? Beautiful. Beautiful. Almost done there, dog. Almost done. You are so old. So, hold on. 16x you brought down, right? Negative 4x squared times negative 3 is what? Negative 4x squared times negative 3. Alright. So, I saw a lot of this. Who got that? Who got this? Give yourself a gold star. Give yourself a gold star. Let's work through it real quick, ladies and gentlemen. Let's work through it. I'm going to burn through this really quick. We're running out of time here. Okay. X times what gets me x cubed? X squared, right? X squared times x minus 3 gets me x cubed minus 3x squared. And I need attention here, especially for those of you that are shaky on this. I need attention. I'm subtracting the whole thing. Same as adding the opposite side, distribute the negative. X cubed minus x cubed, 0. Negative 7x squared plus 3x squared gets me negative 4x squared. Bring down the 16x. Now, x goes into negative 4x squared minus 4x times. Negative 4x times x. Negative 4x squared. Please. Negative 4x times negative 3 plus 12x. Again, I'm subtracting that. Same as having the opposite, so I distribute the negative. Negative 4x squared plus 4x squared, 0. 16x minus 12x. 4x. Bring down the negative 12. X times 1 gives me 4x. Plus 4. 4x minus 12. 0, 0. So my answer is x squared minus 4x plus 4. I'd ask you, what are the factors of that? What are the factors of this guy? Brandon, what are the factors of that? Can it be factored? What are the factors? X minus 2 squared, yes. Yes. So x squared minus 4x plus 4 is the same as, if I factor this, how do I factor x squared? X times x, right? How do I factor 4? There's 2 ways, right? Let's try 2 times 2. They're either both positive or both negative, right? They're both negative because of that guy, right? 2x, negative 2x plus negative 2x gets me negative 4x. These are the factors. Now, I ask you, is it a coincidence that, what is the solution to this? What's the value that makes this function equal to 0? X minus 2 equals 0. Solve for x. I get x equals 2, right? Is it a coincidence that this is the same thing that I got here? No coincidence, right? No coincidence. All right. Now, so, all right. So what did we learn there? What did I learn there? If I have a graph that crosses the x-axis at a point, actually, I'll do my axes in red, and I'll do my so if I got crosses here at negative 3, and it crosses here 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, 16. So if I got a function that crosses at those 3 places, what can I say my factors are? So these are my solutions, but my factors are x plus 3 equals 0, right? That's a factor. That's a factor. This is a solution. That's a factor. Factors in polynomials equal 0. Factors equal 0. Factors equal 0. What do factors equal? 0. Okay? Now, what do you think? We're going to erase this. What are the factors? Now we're at example 1. What are the factors of this polynomial? That's a factor, right? What do factors equal? X equals 0. That's a factor. How about x minus 1? That's a factor, right? And x plus 1. That's a factor. What are my solutions? This one's x equals plus 1. What's the solution to this? X equals negative 1. And what's the solution to this factor? X equals 0, right? So where, pray tell, does this function cross the x-axis? 0, 1, and negative 1. Okay? 0, 1, and negative 1. So, what I do, let's do, we're doing green. There's the y-axis. There's the x-axis. And do this in red. 0. You're not even on the right page, dog. 0, 1, and negative 1. I don't even like that. Can we make this bigger? Let's make this bigger. Let's make each one like 5. So these are divided up into quarters. So negative 1 quarter, negative 1 half, negative 3 quarters, negative 1 is right there. And then same on this side. 1 quarter, 1 half, 3 quarters, 1. So those are your three solutions. And this is going to do something like this. Boom, boom, boom. It's got to do something like that.
It actually did.
On the bottom one, let's do the bottom one. What are my solutions? Oh, I'm sorry, what are my factors? X plus 3. And what are my factors equal? My factors equal 0, right? You're thinking, what's the multiplicity of this factor? How many times does it pop up? 4 times, right? Okay? And you're not going to understand the implications of that yet. But let's put in our axes. There's my y-axis. There's my x-axis. So, what is my solution for that factor? X equals what? Negative 3. So what does it look like? Well, now I'm going to be counting by ones again. Negative 1, negative 2, negative 3. I got a 0 right there. And here's what it looks like. I'll do it in blue. It looks like that. That one just touches the x-axis there, but does not cross. Okay? Who's lost right now? So here's what we're going to do. Here's what we're going to do. Hey. If I got your eyes, I know I have your ears. Everybody's eyes up here. We're going to go into this in more depth tomorrow. Okay? We're going to go into this in more depth tomorrow. Okay. Now, here's what I want you to do. I want you to write down what the problem set is for this lesson. Alright? We're going to do problem set number 2. Here's the problem set. I will also hand out an exit ticket tomorrow. But if you want to see what the problem set looks like, it's number 2.